tell us that the endless forms that Darwin wrote about are not endless. When commercial whaling started at the start of the 20th century, the original populations of whales were somewhere around these numbers shown in the left-hand column: 100,000 right whales, 240,000 humpback whales. Those populations have now been reduced somewhere between 80 to 97%. Even with the moratoriums on whaling, some of which were enacted as early as 1935. So the large cetaceans, some of which you've heard about through David's lecture, are far fewer than there used to be. And you might say, okay, we don't depend on whale meat anymore, and there's whale watching, and maybe those guys are protected. But did we learn our lesson? No, we didn't learn our lesson. Let's look at the vanishing of large ocean fish. Cod, for example. Cod, which you may know, played a critical role in the ability of sailors to sail the open seas and explore new worlds and to settle those new worlds. Cod that were so numerous off the east coast of the United States that sea captains complained of being pestered by the fish. Well, in 1992, the originally enormous Grand Banks fishery off the Canadian coast collapsed. Collapsed completely. The cod populations were absolutely decimated. And we know that rapid evolution in those cod populations preceded their collapse. Rapid morphological evolution, rapid changes in their reproductive rates and at the age at which those fish reproduced. Fishing is a form of artificial selection. Fishing is a selective pressure on fish populations. If done without any consideration for the effect on those populations, it can backfire in our face and there's no more fish. Tuna, marlin, swordfish, similar story. 90% of their biomass, meaning the total number of individuals and their total sizes, has been reduced since the end of World War II. These are, of course, important food stocks. And there's byproducts of this activity. Sharks, for example, are caught in the nets or the long lines that are used for catching these other fish. And you may not be too sympathetic towards this, but nonetheless, these animals play an important role in the ecosystems in the ocean and have for more than 400 million years. Hammerhead sharks, white and thresher populations have declined by more than 75%. So if Bates was to go back to the Amazon, the parrots and butterflies that had enchanted him, some species would be gone. They certainly would be nowhere near as numerous as they were 150 years ago. If Darwin returned to the Galapagos today, he'd find that the very symbols of the islands, the Galapagos tortoise as well as certain finches, are extinct on some islands. The endless forms are not endless. And it's not just species, but entire ecosystems that have been exterminated or damaged. So evolution is not just important for medicine, it's important for nutrition. Understanding evolution is important for nutrition, for human health, and for our economic livelihoods. So I'm going to just close with one thought, and it's a thought that comes from a Nobel laureate a few decades ago, Sir Peter Medawar, who said, the alternative to thinking in evolutionary terms is not to think at all. And I say particularly to your generation that that's an alternative our species can no longer afford. So let's take some questions. Lots of hands. I'll just try to swing across the room. Let's swing over here to the right. Yeah, in brown.
On the chart of all the humans and when different species existed, one of the species stood out as having survived for a long time. Do you know which species off the top of your head that was, and any reason why its span on Earth was so long?
Yeah. When you look at those red bars, there's two things you have to take into account. These are estimates, and sometimes they're an estimate is broad because we don't have exact dating on all of the fossils that may belong to that species. The second may be just what you're inferring, is that the lifespan of that species or of subspecies that are so closely related to it that we can't distinguish them right now may have been fairly extensive. So Homo erectus, for example, seemed to have had a fairly long run. That may be partly due to the amount of territory that a species has covered. It may be in part due to the climate, how harsh the environment was, how many upheavals that species had to confront. So there's a little bit of perhaps luck factor. And some of it may be just how well adapted that species was. There's I think, no textbook answer to your question. Those are really questions that the answers need to be worked on now.
Thank you.
Yeah. Far back right. Yeah, in the tie. Sorry, behind you, and I'll come to you next. Yep.
How do we know that like the different species of hominids were different species, not just different variants? Because like in an earlier lecture, you said that if we found fossil evolved varieties of dogs we'd classify them all as different species.
Right. So paleontologists, and you can ask some on your own because I'm not one, but I'm going to represent their position, is that paleontologists are inferring fossil species from a variety of pieces of data. Some will be the time span. Are these specimens coexisting at the same time at the same place? If they're separated by a fair amount of degree in time, that's one piece of data. The other would be look at morphological characters. Look at, for example, brain size, skeletal form, etc. If those divergences are greater than the range of variation that you might see in living populations, then the inference might be strong that these are separate species. If they're found in different parts of the world, that's also another inference. So this is an area where there's not a cut and dry answer. These conclusions are overturned quite frequently, where something that may have been called two different species, it's now agreed by some further work that that should be made into one species, or something that was identified as a single species is now, from the identification of more specimens, split into two. So it's a bit of detective work, and it reflects the consensus of that dynamic process of testing ideas and generations of scientists wrestling with these ideas. There's been lots and lots of change in perspective in the human fossil record, the hominid fossil record, over the past 150 years, especially as that fossil record grows. And be prepared. You've probably heard there's been some spectacular hominid fossils found within just the last 2 years that are, again, have the potential for upsetting the apple cart of our notions of how this all happened. Okay, let's go back left, gentleman there in gray or black? Yeah, right there. Yep.
Right, yeah, I was wondering, you and Dr. Kingsley were talking about how there was the regulator part of the DNA, and then there was also the protein coding part of the DNA. And I was wondering if either of them are more likely to be mutated than the other.
Great question. So the question is about, is either one, non-coding or coding DNA, more likely to be mutated? In terms of just that event of mutation, no. There's not a difference we see between the propensity of just DNA sequence, wherever it is, to be mutated. But in terms of which types of mutations are more acceptable or more tolerable in the course of evolution, carry the smallest penalty with them, essentially the best ratio of advantage to disadvantage. For the evolution of form, it may well be that it's changes in these genetic switches, because they don't disrupt the function of the gene elsewhere, may be the much more common form of evolution in DNA sequence in terms of the evolution of form than changes in coding regions. So that's not to say the mutation sites of mutation are different. It just says that what selection can use may be biased towards non-coding DNA in these cases. I'm going to wrap up there. Thank you very much.
Thank you, Sean Carroll, for a terrific final lecture in our series. To make a holiday lecture series, it requires a lot of people, and I want to thank the student audience for your terrific attention and great questions. Thanks to the production team, and especially thank you to our speakers. From all of us at the Howard Hughes Medical Institute, happy holidays.